Okay, next we're going to have Steve Dower talking about Python on Windows.
Okay, some of you are probably confused, because the title of this talk was fairly clear. I installed Python on Windows. I know a lot of you probably haven't used Windows in the last few years, and it looks a little bit different now, right? I promise this is actually Windows. I'm in my system directory. I have exe files everywhere. I can run calculator. And if I take this out of full screen, Excel, Visual Studio, all the Windows apps are here because this is Windows. And yet I just installed Python using sudo apt-get, and it even says it's Linux Python, and I can run it again on Linux. This is Bash for Windows. This is new in Windows 10. In the recent updates, you can have a full Linux distro installed on Windows. This is not a virtual machine. This is not isolated from the rest of the machine. This is the Windows kernel with the Linux user mode right on top of it. We shim all the kernel calls. They run directly against Windows. I can modify files on my Windows file system here. I can modify Linux files from my Windows system. It's all interactive, and you get Python installed as part of that. But what you really came for is, let's install Python on Windows. So let me jump here to the actual Windows installer. And again, if you haven't done this recently, you may notice some changes. So I'm going to start this installing and let it run for a bit. In the past, I'd get to spend a lot longer talking about what the installer's doing. But now it's considerably quicker than it used to be, so I'm not going to get that chance. But a few things that you'll notice, it didn't ask me to be an administrator. It just ran the install. In Python 3.5, we brought this in. Python can now install just for the current user, and that's actually the default, which means if you don't have admin privileges on your machine, you can still install and use it. A lot of the components are optional now. It's a lot more reliable to add and remove certain features. If you don't want TickleTK, if you don't want pip, if you don't want documentation, you don't have to install them. And if you start from the web installer, you don't even have to download them. If you decide later to add them in, it works just fine. For those of you who remember the grand old days of Python 2.5 and 2.7 on Windows, you may not remember that kind of thing so fondly, but now it's perfectly fine to do that. And it's done. Now, often at this point, I'd bring up a command prompt and go, C, Python 3.6, python.exe. That's not going to work, because we changed where it's installed. The reason we did that is because putting it in the root directory is a really, really big security hole. Turns out root directory on Windows is writable by everyone, which means if you have an administrator who uses Python and a non-administrator who uses Python, that non-administrator can drop any file, such as your site customize, any package, any encoding, make any changes they want, and the administrator is going to run it with full privileges. It's not a great idea. So where did it install? That is a question that has not always been easy to discover. But I will point out that Visual Studio has already picked up that it's been installed, despite the fact that I haven't had to tell it anything. So clearly, at some point, someone knows where Python is. I'll jump back to this, but let me go to regedit. This is where the text gets really small. I'm sorry. Some things don't scale nicely. But I'm here in the Python core registry key. If you've hacked around on Windows in any way, shape, or form, you may know about this key. It's where CPython registers itself. Historically, tools will look in this to figure out where Python is installed if they want to use it. All the IDEs, anything on Windows that needs to run Python will look here. And as a result, all of the other distros will also stick their registry keys in this folder, overriding the CPython ones. If you've ever tried installing, say, Anaconda and then WinPython and then uninstalling one, you just broke everything because they all stomp on each other. So one of the PEPs that we had in for Python 3.6 is PEP 514. This is basically just formalizing what Python already does with regards to the registry. You probably don't need to know or care about this, but I'll show you why you'll benefit from it. What PEP 514 defines is the structure, where various Python interpreters write their registration, what that registration is, what metadata is included, and how to avoid collisions. So you can see here, there's a set of metadata. We have a display name, support URL, architecture, the language version, and the installation version. None of this existed previously. This is new in 3.6. And any other Python interpreter that may be installed can also write this information. What this gives us is the ability to distinguish between an Anaconda install and a Python install of the same version, because they've registered themselves in different places. We've pulled out of this registration the various company names. Python 3.6 is from Python Software Foundation. Anaconda is from Continuum Analytics. We can bring this website, if you need help with it, we can bring that up in the tooling because it's in the registry, and we have a different website for Continuum's packages versus the official CPython packages. This is accessible to any tooling on Windows, and it's the new standard and approved way for you to have many, many interpreters on Windows. Again, largely Linux developers are going to go, why would you do that? And all the Windows developers basically say, why wouldn't you do that? We love having many, many interpreters installed, and this is the way that you get to distinguish between them. So, next up is we have brand new icons for 3.6. I love these. This was a spur-of-the-moment email on my part. Went to one of the developers who works at, designers who works at Microsoft, where I work. Just sent her an email and said, hey, these are what our current icons look like. Do you think you can make some better ones? And about a day later, she came back with these. And I love these icons. Look at that launcher. These are installed with Python 3.6. They'll apply to any files you have. So Python source files, PYDs. The installer gets a nice new icon. It's a very subtle touch, but it makes it so much nicer and so much just more pleasant to be looking at a directory full of Python files when they look like this. All right, I'm about to go to the elephant in the room, which everyone kind of knows about. Compiling packages. That has improved with Python 3.6. It improved largely with Python 3.5. And frankly, one of the biggest ways it improved was when I published a blog post, which is at this URL, that basically just has a table saying, if you have this version of Python, you download the tools from here. This solves a lot of problems for a lot of people, but recently, work done at Microsoft has actually made this even easier because we have a new Visual Studio installer. So people that have installed Visual Studio in the past have one big complaint with it, and that's that it takes over their entire hard drive. If you have less than 10 gig free, you could not install Visual Studio previously. And 10 gigs is a decent amount of space. Visual Studio 2017 has focused things a lot more. You get a very high top-level option for what scenarios you want to support. One of those is Python development. You can see it's already selected there. This will give you a Visual Studio where you can edit, debug, profile, all the basic Python stuff. The cool bit in this session is this Python native development tools. It's one checkbox. Hidden behind that checkbox is all of the C++ compilers for Python 3.5 onwards, all of the headers, all of the libraries, so that when you install that component, you get enough on your machine to not only compile Python packages, you can compile Python itself through one checkbox. And the entire install at that point, I think, varies between 3 and 4 gig, depending on what you already have had previously. Considerably smaller. If you leave out the C++ stuff and just want a Python editor, Visual Studio is down to about 1 gigabyte, and even then you can still debug and do a whole lot more stuff than with something as simple as a basic text editor. The other project that's going on that I want to draw some attention to is MinGWPy. So the obvious response to not being able to get the same compiler from Microsoft that's used for CPython is to get the GCC toolchain. And particularly if you need to include G4tran or something along those lines in the build, MinGW is often the way to do it. Unfortunately, MinGW's compilers generate binaries that don't quite work with the Python ones, and so you get random crashes or just random failures, corruption, things fall apart in bad ways. MinGWPy is a project to resolve all of those. They're working with people at Microsoft on and off, and not as productively as I wish we got to, but they are working with people from Microsoft. We are getting a build of MinGW that can produce Python binaries that are fully compatible with the CPython official releases, so that even if you don't have access to the Microsoft tools, you can build using these tools and get a very compatible extension. They need contributors, they need people to test stuff, they need people to download and use it. They need some things from me as well, so I'm working on that. But this is a project that's ongoing that I want to draw some attention to. Long term, this is the way that NumPy and SciPy and all of those projects will work on Windows. All right, I'm going to jump to a more subtle problem that has been fixed in recent versions of Python. And this is kind of a hard topic, but it turns out that in earlier versions of Python, we actively hurt a lot of people. Put yourself in this position. You've immigrated to the US at the age of 10. Now you're at high school. You're going to school now, which is great. I don't know what country you escaped from. In my example, it's going to be Armenia. But you're here now. And you're in school, and you're being taught Python. You've got a programming class. That's great. High school programming class. And the first thing that they get you to do is this basic little thing asking you, what is your name? Or what is your name? My name is now spelt like this for the remainder of this session. And so here I am, you know, I'm at school, learning to code, and I'm like, great, this is so exciting. Skills, what is your name? Oh, here we go. Yeah. And this is Python 3.5 doing this. This is not even the legacy versions of Python. This is the one that, up until we released Python 3.6, was the best available. And we're telling kids, this is your name in Python. If I have a module with that name, and I try to import it, my name is invalid syntax. I'm not proud of this. Though obviously I'm only telling this story because guess what works in Python 3.6 that didn't work in Python 3.5? And I can import it. This problem has led to everything from people with names from any other culture not being able to install packages with pip, not being able to do basic exercises in Python. And this is now a problem that has, to a large extent, been resolved nearly completely, at least from the Python interpreter side. Let me go to a brief history lesson on why this came about, and what we did to fix it. Long time ago, probably in the 80s, I don't know, I was like that tall, we decided that 7 bits was enough to represent all the letters in the world. Because just like baseball, the entire world consists of one country. And so 7 bits was enough. And then very shortly after that, we discovered, oh no, 7 bits is not enough, let's go with 8. 7 bits gives us 128 letters, that's A through Z twice, Z not Z deliberately for the other non-US citizens in the room. Couple of numbers, bit of punctuation, that's plenty. We doubled it to 8 bits. What do we do with the other half of that? We have another 128 characters, what do we put there? For whatever reasons, the people who thought the first 128 was enough decided to do box art in that. So that's the most important thing to put in those extra spaces. And oddly enough, the Greeks decided to put Greek characters there. Russians put Cyrillic characters there. Most of Southeast Asia kind of looked at it and said, 256 is, we have 10,000 characters each. We're not even going to try this. But we ended up in a situation where the top half of the character space depended on where you were. Windows implemented this as a configuration option. It's known as the active code page, very similar to the locale settings you're used to on other platforms. And again, for context, this is the early 90s. It's all pre-Unicode. So Unicode comes along. And suddenly, instead of saying, oh, we have 8 bits for this, we have a roughly infinite code space, and let's figure out different ways to encode it. And you end up with encodings that can do essentially unlimited numbers of characters. But when you switch to that, all of your old code either has to be broken or continue working. Some companies that are well known for pocket devices will say, let's break the world and move on. Had that been done by Microsoft at the time, we wouldn't have this problem as recently as Python 3.5. Microsoft took their usual approach and said, let's keep that working and make a new set of APIs that use the new types, and everyone will be happy. And certainly everyone that had paid a contracting company for their expensive line of business software was very happy that they didn't have to pay another one to keep working. But this does mean that right up until today, Windows 10, latest builds, still have this split world. You have a configuration option that limits you to 256 different characters, or the Unicode option that gives you the whole world. Up until Python 3.5, we were still using the old one. And again, for context, Python came about at a time before Unicode as well. So that makes sense. We were still using the old APIs, which means whenever you typed in your name, if that didn't fit into the active code page, whatever that happened to be, then we would lose information because we'd send it through those old APIs. What we changed for 3.6 was went through everywhere we were doing that and fixed it so that now we use the Unicode APIs, which means when we get input from the console, we don't send it through that filter that turns entirely legitimate letters outside the US into question marks. When you pass a file name out to try and read it back from the file system, we don't pass it through the filter that says, oh, this file doesn't exist because you had an umlaut over something. Internally, Windows uses Unicode everywhere. As of Python 3.6, Python internally uses Unicode to talk to Windows. And that's a huge step forward as far as engaging the entire world and having everyone be able to use Python successfully and print their own name. What else is new? App local deployment is something that a few people really, really care about and most people don't. But on Windows, this is a big thing. This is when you install some program and it has a copy of Python hidden inside it and you don't even know. That was messy in the past. Python 3.6 is continuing to iterate on this, particularly on Windows, and it's getting considerably better. You can now have programs that will install just through a regular installer, run against Python, and you never see it. Great example of this, the command line tool for Azure that's come out of Microsoft has an installer that embeds Python, it hides it, you don't see it because we can do this. Profile-guided optimization has been turned back on for Python. 3.6 we turned it back on, we went through in 3.5 and got a whole lot of bugs fixed. I sat down with one of the devs and said, why is this generating such bad code right here? And he said, because it's a bug. And we said, can we fix the bug? And he said, yes. And so we fixed it. And now it's turned back on, which means you get an automatically faster interpreter than you did before, because we run it through its paces and let the optimizer improve the most important code paths. And continuous integration tools are really coming along. AppVeyor is the one with the deployment settings that everyone can easily find online. Visual Studio Team System is another one that can build Python packages for Windows with comparative ease compared to all the alternatives to those. These tools are functional and actively used. You are probably installing packages on Windows built with these. It's no longer a case of someone has to manually pull the code down onto their own machine, build it, and publish. We have the same great tools coming up for wherever you are building from. Python has always had a reputation for being one of the best languages to write once, run anywhere. And this is still the case. This is possibly even more the case than in the past. The core development team is committed to your code being portable between running on Linux and on Mac when that's how you write the code to be. We want to filter out anything that makes it harder to do that, any differences between the platforms that show up in portable code, we want to get rid of. And if you come across them, please file them because we do want to fix that. I want to throw out a thanks to Microsoft Corporation and Continuum Analytics and a big range of other people that have contributed to this. These organizations and individuals are actively investing in making Python developers on Windows the happiest developers. My name's Steve Dower. I'm an engineer at Microsoft. I'll be at our Microsoft booth. Feel free to come chat to me, tweet at me. Thank you for coming.
Lots of time for questions. If there are questions, come to the microphones, please.
There's always questions.
Sure. So I have two questions. First, that's a really good skin. So what distro and window manager are you running? It looks exactly like Windows 10.
Yeah, it's impressive, isn't it?
Yeah. So my actual question, you said you fixed this. There was a problem in 3.5 and you fixed it for 3.6. Are you talking specifically about Windows there, or was this actually a problem on POSIX operating systems like Mac OS 10 and Linux?
So Mac OS 10 I think was always fine because we've always assumed that UTF-8 is the encoding everywhere, because Mac OS was one of those operating systems that at some point said everyone before this point is broken, and so we didn't have the option of continuing any old encoding system. It all moved to Unicode, and we moved with it. Some POSIX systems, as I don't see anyone in the room who's working on the UTF-8 PEPs right now, but some POSIX systems certainly have this issue still. And there's a huge debate going on as to whether they are misconfigured or misdesigned. But it is certainly possible to have these problems on POSIX systems. Most of the time we don't, because a lot of them have sensible defaults for Unicode, and we pick them up and handle that correctly. One of the other big problems is that Windows internally went for UTF-16 rather than UTF-8. And the transition between those two is very different from the transition from single byte characters to UTF-8, which is also single byte. So there was more work involved because of the change of data type, but in large part this is always a problem on Windows, occasionally a problem on Linux, and was fixed by Mac, preventing you from using your old code.
Technically, Microsoft's Unicode APIs take UCS2, don't they? Not UTF-16.
This is why I left lots of time for questions. Yes.
Hi. I use both Linux and Windows, and I use Python on both Linux and Windows, and I have come to rely a lot on virtual environments, and I wanted to know if there was plans to actually have virtual environments integrated with Visual Studio and other tooling in Microsoft.
Yeah, so good question. I am the person, like the best person to ask about that. There are very strong desires to do all of that. I do, in fact, have a very experimental preview of being able to run code from Visual Studio inside the bash for Windows that I showed at the start and give you the F5 debugging experience while you're actually running against Linux. We currently support a manually set up remote debugging thing, so you can start the agent on the remote machine and then attach to it from Windows, and that works into virtual machines as well. As for very specific integration, it's one of these problems where there's 100 different ways we could go, and it's picking the one, and to some extent we get to do one and have to tell everyone else you need to fit this model. So we're not rushing into anything too quickly. I'd love to chat in more detail about your use case and get a feel for what direction would most benefit you. And that goes to anyone. I'd love to talk to anyone about your use case and get a feel for what direction best helps you, so we can make a good decision on that. So very strong desires, no concrete plans right now.
Is CP_UTF-8 ever going to be a thing?
I mean, it is a thing, and we largely wish it wasn't a thing. So for those who aren't familiar, CP_UTF-8 is kind of a hack. So when we talk about code pages, they come with CP numbers, CP1525, CP437. That is the identifier for what shows up in that top half of character set that I was talking about. There is one in Windows, well, there's a couple in Windows that are CP 65000, 65001 that say, even though we're pretending to be like a half code page, actually interpret it as UTF-8. And that works great about half the time, and the other half of the time it just fails miserably. And the best approach is, quite honestly, Unicode through the Unicode APIs rather than trying to force it through the old style APIs.
Hi, with WSL enabling you to use the exact same Python binary compiled on the exact same version of GCC on your Linux server as your development environment, what's the use case for maintaining tools like the MinGW port?
So the use case is largely that a lot of people have Windows production servers, and WSL, the Windows subsystem for Linux, is not a production tool right now. Maybe it will get there at one point, but at the moment it's very much a developer tool. It's not something that you go and enable on, if you have 1,000 analysts at your company, you don't turn it on for them. If you have highly optimized production servers where you've already stripped out as much of Windows as you possibly can to reduce the size, you don't turn that on and start running inside that. And that's basically the reason. You're not going to have that enabled on all of the machines. And there honestly is not that much benefit, if any benefit, in running something inside WSL compared to running it on an actual Linux install. And so it is really prototyping, development, debugging to some extent tool. There are some subtle differences. So if you're debugging a really, really weird edge case, you do have to ask the question, is this a difference because we're actually going through the Windows kernel, not the Linux kernel? How does that affect my deployment? So it's not, but it's not production ready, and it's not meant to be production ready. It's development ready, and then you do transfer, final integration tests before you hit the final thing. The idea is to give you a Windows environment with the tooling you're used to there, and be able to use it. And that doesn't transfer to someone whose tooling is Pandas and Excel. They are probably not the target audience for enabling a bash shell and using that. In some cases, certainly. We have a lot of other tools that are more valuable for those people, like running Jupyter notebooks, either locally or remote. I think that answers it. I feel like I'm rambling now, so it's probably answered at some point. Is that? But there seem to be no other questions, so I can keep rambling. How far under time did I go? It's Larry again. Okay. Cool. And then it's a break, so we can go as long as we want.
Just a quick question about the Linux version that was running under, it's WSL, right?
Yes.
Yeah. Does that one have the encoding problem, or can you paste in our Armenian friend's name?
Let's try. Whoa, did I just disconnect? Oh, there's that. There's the link that I had up before. PowerPoint finally opened it. Oh, and then I disconnect again. Okay.
Okay, now I know you're not running a skin, because Linux actually has no problem connecting to external displays anymore.
I mean, if this doesn't work, then I'm going to point at, I think it's Canonical who does the images for us. Do we have a Canonical rep here to blame?
Not your fault. Of course not.
It's gone off the screen, but it did actually work, so good job.
So it works on WSL and not on Linux.
Works, well, that one, so yeah. We have a properly configured Ubuntu build running on WSL right now that has UTF-8 and is using it. And presumably I could uninstall or remove that and it would stop working. That was not a demo I was prepared to do.
So on the encoding problem, how far did that extend outside of just the console input?
So the biggest case where it kept showing up was any code that was using bytes as file system paths. Okay. So Python, like all throughout Python, supports using either bytes or strings as the type of a file system path. So you could pass a string to open with the file name, or you could pass bytes to open with the file name. Reason for that is bytes are native on POSIX, and so if you get a path from the operating system, the native encoding is bytes. It's essentially a blob. It doesn't necessarily have an interpretation via an encoding. And so you want to be able to pass bytes back without transforming it at all, so you don't lose anything. That's why that's there. Windows, the native one, is Unicode, and so by default you'd get back a string, which is not going to lose anything because in Python string is Unicode encoded. And again, this is Python 3, this is not Python 2 anymore. And so you'd want to pass that string back in on Windows. Some libraries take, there's also a mechanism to use strings on POSIX safely without losing any information. So you can encode through what's known as surrogate escape, which will keep any unencodable characters around so that you get the right thing back at the end. What many developers would do is say, oh, it's faster on my machine to use bytes everywhere because their machine is a POSIX machine, and so they'll use bytes everywhere, which on Windows would convert the Windows path into bytes, lose the information, lose the non-ASCII characters, and then go back to the file system and it's got a question mark and try to find it. That was quite a common thing that we saw enough. The fix that was made there, for those who aren't familiar, Python has a file system encoding that is part of its state. And on POSIX, that's picked up from the operating system. On Windows, that used to be picked up from the operating system, but because of the changes we made, it's now actually a completely internal Python thing. That encoding on Python is now UTF-8, and basically it says, if you ask for something from the operating system as bytes, we'll encode it as UTF-8. And if you give bytes, we'll decode it from UTF-8 and pass it as a string that that Windows expects. So we cleaned up a whole lot of file system path issues, potentially broke some code, but I have actually heard far more thanks from the big libraries who now don't have to have code like if on Windows, use string, else use bytes everywhere, because you can safely use bytes. Bytes as paths were actually deprecated on Windows since 3.3. It was never noisy, but they were officially deprecated. You are not supposed to be relying on passing bytes as paths on Windows because of this issue. And rather than removing the functionality completely, we went in and fixed it and said now it's supported again. So you can totally use bytes for paths on Windows. You get a slight performance hit. There's an extra transcoding involved. But you can do it. It's safe. It's fully supported. Those bytes are encoded as UTF-8. But the correct way to encode them is to use os.fsencode, os.fsdecode, which will use the file system options. Like I said, I'm happy to chat more. Feel free to come chat with me now. Come by the Microsoft booth, or I'll be hanging around. Thank you all for coming. Okay, some of you are probably confused, because the title of this talk was fairly clear. I installed Python on Windows. I know a lot of you probably haven't used Windows in the last few years, and it looks a little bit different now, right? I promise this is actually Windows. I'm in my system directory. I have exe files everywhere. I can run calculator. And if I take this out of full screen, Excel, Visual Studio, all the Windows apps are here because this is Windows. And yet I just installed Python using sudo apt-get, and it even says it's Linux Python, and I can run it again on Linux. This is Bash for Windows. This is new in Windows 10 in the recent updates. A lot of the components are optional now. It's a lot more reliable to add and remove certain features. If you don't want TickleTK, if you don't want pip, if you don't want documentation, you don't have to install them. And if you start from the web installer, you don't even have to download them. If you decide later to add them in, it works just fine. For those of you who remember the grand old days of Python 2.5 and 2.7 on Windows, you may not remember that kind of thing so fondly, but now it's perfectly fine to do that. And it's done. Now, often at this point, I'd bring up a command prompt and go C Python 3.6, python.exe. That's not going to work because we changed where it's installed. The reason we did that is because putting it in the root directory is a really, really big security hole. Turns out root directory on Windows is writable by everyone, which means if you have an administrator who uses Python and a non-administrator who uses Python, that non-administrator can drop any file, such as your site customize, any package, any encoding, make any changes they want, and the administrator is going to run it with full privileges. It's not a great idea. So where did it install? That is a question that has... People in the back rows, feel free to come forward. I have a lot of demos and a lot of small text.
Okay, next we're going to have Steve Dower talking about Python on Windows.
Not always been easy to discover. But I will point out that Visual Studio has already picked up that it's been installed, despite the fact that I haven't had to tell it anything. So clearly, at some point, someone knows where Python is. I'll jump back to this, but let me go to regedit. This is where the text gets really small. I'm sorry. Some things don't scale nicely. But I'm here in the Python core registry key. If you've hacked around on Windows in any way, shape, or form, you may know about this key. It's where CPython registers itself. Historically, tools will look in this to figure out where Python is installed if they want to use it. All the IDEs, anything on Windows that needs to run Python will look here. And as a result, all of the other distros will also stick their registry keys in this folder, overriding the CPython ones. If you've ever tried installing, say, Anaconda and then WinPython and then uninstalling one, you just broke everything because they all stomp on each other. So one of the PEPs that we had in for Python 3.6 is PEP 514. This is basically just formalizing what Python already does with regards to the registry. You probably don't. You can have a full Linux distro installed on Windows. This is not a virtual machine. This is not isolated from the rest of the machine. This is the Windows kernel with the Linux user mode right on top of it. We shim all the kernel calls. They run directly against Windows. I can modify files on my Windows file system here. I can modify Linux files from my Windows system. It's all interactive, and you get Python installed as part of that. But what you really came for is, let's install Python on Windows. So let me jump here to the actual Windows installer. And again, if you haven't done this recently, you may notice some changes. So I'm going to start this installing and let it run for a bit. In the past, I'd get to spend a lot longer talking about what the installer's doing, but now it's considerably quicker than it used to be, so I'm not going to get that chance. But a few things that you'll notice, it didn't ask me to be an administrator. It just ran the install. In Python 3.5, we brought this in. Python can now install just for the current user, and that's actually the default, which means if you don't have admin privileges on your machine, you can still install and use it.